All right, here we go. This is problem 9, A, B, and C. So we're just asked to solve these and also note extraneous solutions. So let's take a look at problem 1 here, problem A. Now, first of all, what do we need to do? We need to state the domain. The domain is going to tell us if we have extraneous solutions. Extraneous solution in this context, I believe they're asking you to basically say if there's a solution that is not allowed, say that it's extraneous. It doesn't work. And what type of solution is not allowed in an equation like these? Well, there's a rule in maths that says you may not divide by 0 because, believe it or not, division by 0 equals infinity, and infinity is not defined as a solution here in this case. So, or it approaches infinity. Think about it. 1 divided by 0.1 is quite a bit. And 1 divided by 0.0000000000001 is even larger of a number. Again, you're just cutting that 1 into all these little pieces and giving it to all those, it's just, it approaches infinity as you approach 0. And so division by 0 is not allowed because it actually approaches infinity. And so what would cause division by 0? These are fractions. Well, we simply take the bottom of the fraction, we say x minus 3 equals 0. When does this happen? Well, we'll just solve this as a one-step equation. We add a 3 to both sides of the equation, and we get x is equal to 3. So, same over here. Let's do the same so we know this fraction, this fraction. Division by 0 occurs if, and only if, x equals 3. So x equals 3 is not in the domain, meaning it's an x value that we are not allowed to use. Okay. So let's solve this problem and see if we get an extraneous solution. We may or may not. But either way, we're going to find some value for x. So let's start by let me make sure I didn't transcribe the problem wrong here. I would not want to solve this without. All right. So, easy. All we have to do is isolate our x values. And how do we do that? Well, step 1, we're going to multiply the top and the bottom of, well, it's easiest to isolate this 2 on this side. So what we get is 2x over x minus 3 plus 2 equal to 2 over x minus 3. But let's also multiply this top by x minus 3 such that we turn this into a 1. X minus 3 divided by x minus 3 is 1. And if we do that to this side to cancel these, turn this into 2 times 1, then we also have to do it to this side, but we have to do it to both elements of this side. So x minus 3 will be multiplied by both of those. So what this actually ends up being, I'm going to move this for now. This actually ends up being is this is equal to 2 times 1, or just 2 on that side. This will be 2x times x minus 3 divided by x minus 3 plus 2 times x minus 3. Because this will distribute. This distributes to this, and this distributes to that. So that's why this got that term in the front, this got that. Now what's great is we also have cancellation here. 2x times x minus 3 divided by x minus 3. This is just x minus 3 divided by x minus 3. That's 1. This becomes 2x times 1 plus 2 times x minus 3 is equal to 2. And now we simply have to FOIL this out. Shoot, we're running out of space. So if we continue this over here, what we get is 2x, 2 times x, then 2 times 3, so we'll have the 2x from here, plus 2x from this term being multiplied by that, plus 2 times negative 3, which will end up being negative 6, so let's just write that as negative 6, which is minus 6 essentially, is equal to 2. Now if we combine like terms, we get 4x, 2x plus 2x is 4x. We have this minus 6 is equal to 2. And if we move this minus 6 to the other side by adding a positive 6 to both sides of the equation, what we get is 4x is equal to 8, or, we extend the bottom here, x is equal, let's not skip this, we'll divide 4 out from that side and 4 out from that side. What we get is x times 1 is equal to 8 divided by 4, which is just 2. And the solution to our equation is x equals 2. Now, if we're wondering if this is true, we can always go and check this by plugging it back into our equation here. Is it true that if we let x equal 2, will this equal the same thing? And what we get is 2 times 2 over 2 minus 3 plus 2 is equal to 2. You don't have to do this, but if you're really nervous about whether your answer is correct, you can. You might get some credit for it, even if you're wrong, just showing that you know how to protect your work. So let's see, this is 4 divided by 2 minus 3. It's 4 divided by negative 1, which is just negative 4. So negative 4 plus 2 is equal to 2 divided by 2 minus 3, which is negative 1, which is really just negative 2. Is this true? Well, negative 4 plus 2 is indeed negative 2, and negative 2 does equal negative 2. And so our solution is correct. Is our solution extraneous? Is x equals 2 an extraneous solution? No, because we checked our domain. Our domain said the only time we're going to get an extraneous solution in this case is if we have a solution that is not defined. The only undefined solution is when x equals 3, because then this blows up to infinity. We have division by 0, not allowed, undefined. So again, this would be our domain restriction, and you can write that as x does not equal negative 3 if you want. Your professor will very likely understand what you're talking about. And you can say there's no extraneous solutions because x equals negative 3 is not a solution. Well, you don't even have to write it, just write no extraneous solutions in this case. It's when there is an extraneous solution that you'll have to note this is an extraneous solution. So that's that problem. Now let's take a look at this next problem. Just getting that out of the way because it's super messy. Alright, so x plus 3, okay, this one's actually easier. In this case, we need to find our extraneous solutions, which are going to be x plus 2. You look at the bottom of the fraction here, set it equal to 0, figure out what x needs to be for this to be true. It turns out we add a negative 2 to both sides. X equals negative 2 is not allowed. And we can write that by just doing a line through there. X does not equal negative 2. If x were allowed to equal negative 2, we would have division by 0. Division by 0 is illegal, so we can't do that. If we find that we have a solution where x equals negative 2, that would be an extraneous solution, and it's not allowed. You'd have to note that. But we also have a fraction over here, x minus 10 is in the denominator here. So let's set it equal to 0, and let's see, we add a positive 10 to both sides, positive 10, and we find that x equals 10 is not allowed. That's well. Great. X equals 10 is not allowed. So now we know our extraneous solutions. Let's solve our problem and see what our actual solutions are. So how do we do this? Essentially, we're trying to isolate one of these on one side of our equation. So in this case, you can cross multiply is what I would recommend. But essentially, it's the same as what we did before. So we'll do an x minus 10 on this side to get rid of the x minus 10 on this side. And we'll turn this into a 1. But again, we would have to multiply this by x minus 10. Okay, great. And over here, we want to get rid of the x plus 2. So let's also multiply top by x plus 2. And we have to do it to this side as well. And what this gives is over here, we have the cancellation of those terms because that just equals 1. That becomes a factor of 1. And over here, we have a cancellation of those. That just equals 1. Becomes a factor of 1. And what we're left with is x minus 10 times x plus 3 is equal to x minus 6 times x plus 2. And now it's time to FOIL. And foiling is always fun. So much fun. Well, I guess we could FOIL. We don't have to FOIL. Actually, let's not FOIL. Let's just solve this like we would do a quadratic. So everything's already factorized. What we need to do is we actually need to rearrange this and move one of these to one side. So let's see. X minus 10 times x plus 3. We'll subtract, what we're going to do is we're going to subtract x minus 6 times x plus 2 from this side of the equation, and we're also going to subtract it from this side of the equation. And what we get is cancellation on this side. This turns to 0. And over here we'll have the x minus 6 times x plus 2. And this will be equal to 0. Okay. Let me just double check that I am solving the correct problem. Anyway, I think I am. Didn't make any typos. Okay, so in this case, what is our solution? Well, shoot, I freaking messed it up. We actually do have to FOIL these out. So annoying. That's fun. We'll do that in part 2.